In 18 months, the Pacific Ocean has swung from La Niña all the way into a strengthening El Niño, and it could not have picked a worse time. 2/3 of the United States is already drying out. A fire in Utah has hit nearly 97,000 acres with zero containment, and the ocean pattern now building offshore tilts the odds toward all of it deepening into the fall. Today, what the data actually shows about America's drought, and the question no one wants to ask, what does the West look like when the real strength of this El Niño finally arrives? Right now, roughly 2 out of every 3 acres of the continental United States are drying out. That is not a forecast, and it is not a warning about something that might happen later this summer. It is the current reading from the latest United States Drought Monitor, the weekly map that federal scientists use to track exactly how much of the country is running short on water. As of the most recent release, valid for the week of June 30th, 67.02% of the lower 48 states is in the abnormally dry category or worse, 2/3 of the country, and it is getting worse in the places that matter most. Here's the problem with a story like this one. A drought does not arrive. It does not make landfall, it does not shake the ground, and it does not erupt. There is no single moment you can point a camera at, which is exactly why the biggest environmental story unfolding across America this week is also the one almost nobody is talking about. It has been building for weeks, quietly, acre by acre, and it has now reached the point where it is producing consequences you cannot ignore. Because while the drought itself stays invisible, its symptoms do not. A little over a week ago, a fire started in Utah. As of the latest report from the National Interagency Fire Center, it has burned nearly 97,000 acres, and firefighters have contained exactly 0% of it. That fire is not the story. That fire is a symptom. The drought underneath it is the disease. And today we are going to trace the disease all the way down. What the data actually shows, why one improving number is hiding a worsening emergency, and what happens to the American West when the hottest stretch of the summer arrives this weekend on ground that is already this dry. Let me show you what that 2/3 figure really contains, because the headline number is only the surface. The Drought Monitor sorts the country into 5 categories, and each one is a step down into deeper trouble. The mildest, D0, is abnormally dry. Not technically drought yet, but the early edge of it, where soils are starting to lose moisture and streams are running low. That is the 67% figure. But drought proper begins at the next level. Nearly 48% of the country, 47.84% to be exact, is an outright drought, category D1 or worse. Almost a third of the country, 30.7%, has reached severe drought, D2. Just under 11% has crossed into extreme drought, D3, which means better than 1 acre in 10 of the entire continental United States is sitting in one of the 2 worst drought categories on the scale. And 1% of the country has reached the top of the scale entirely, D4, exceptional drought. That is the level defined by widespread crop and pasture losses, and by water shortages in reservoirs, streams, and wells serious enough to create genuine water emergencies. 1% may sound small, but understand what it represents. That is not a scattered patch of dryness. That is a concentrated zone of maximum stress, the places where the taps and the fields and the reservoirs are already failing. And it sits at the peak of a pyramid that has 2/3 of the country underneath it. And these categories are not arbitrary lines drawn on a map by someone in an office. Each step is anchored to real, measurable conditions on the ground. Soil moisture readings, stream flow gauges, reservoir levels, snowpack, and the actual state of crops and pasture. When the map says D3, it means ranchers are hauling water and selling off cattle they can no longer feed. When it says D4, it means wells are going dry and communities are staring at genuine water restrictions. So this is not a regional dry spell, and it is not a statistical abstraction. This is a continent-scale drying event measured 6 different ways, and the fire in Utah is what it looks like when that drying finally reaches the ground. Well, now I have to be straight with you about something, because it matters, and because most coverage of drought skips right past it. Over the past week, one of these numbers actually got better. The severe drought figure, the D2 and above coverage, improved by 2.84 percentage points compared to the week before. On paper, that looks like relief. If you only read the top-line national number, you might conclude the drought is easing. It is not, and here is why. That improvement came almost entirely from localized rainfall in the eastern half of the country. Rain fell where the drought was milder, nudged a few eastern regions back across a category line, and pulled the national average down. But averages lie. While that was happening in the east, the west was going the other direction, intensifying, drying further, and feeding the fires that are burning right now. A single national percentage can improve at the exact same time a regional catastrophe gets worse, because the number that made headlines and the ground that is actually on fire are 2,000 miles apart. This is the trap with drought reporting, and it is why the story is so easy to miss. The one honest number that ticked in the right direction this week is real, but it is a rounding detail against a structural picture. The overall footprint is still historically large. The West is still getting drier, and as you are about to see, a major heat event is loading for this weekend that will erase those marginal eastern gains through a mechanism most people have never heard of. To understand that mechanism, you have to understand that a drought is not only about the rain that stops falling, it is also about the water that gets pulled back out of the ground. Most of us think of drought as a simple subtraction problem. Rain stops, water runs out, drought begins. But that is only half of it, and it is the half everyone knows. The other half is what scientists call evaporative demand, and it is the hidden engine driving what you are seeing this summer. Think of it as the atmosphere's thirst, how aggressively the air itself pulls moisture up and out of the soil, the plants, and the reservoirs. Here is the piece that changes everything. The warmer the air gets, the thirstier it gets, and it does not scale gently. For every 1 degree Celsius the atmosphere warms, its capacity to hold water vapor rises by roughly 7%. That relationship has a name, the Clausius-Clapeyron relationship, and it is not a theory or projection. It is basic physics, as reliable as gravity. A hotter atmosphere is a more powerful sponge, and it wrings moisture out of the ground faster. What that means in practice is that the exact same rainfall deficit produces a much deeper drought in a hot year than in a cool one. You can get identical shortfalls in rain, but if one year runs hotter, the atmosphere pulls the remaining moisture out of the soil faster, and the drought bites harder. This is why the heat and the drought this summer are not two separate stories that happen to overlap. The heat is not sitting next to the drought. The heat is feeding it. And that feeding relationship gets even more dangerous when it starts to loop back on itself. Once a drought gets going, it does something genuinely alarming. It starts to reinforce itself. This is the part that turns a bad dry spell into a runaway one, and it works like this. When soil has moisture in it, the sun's energy goes partly into evaporating that water, which cools the surface, the same way sweat cools your skin. That is the ground's built-in air conditioning. But when the soil is already dried out, there is no moisture left to evaporate, so almost all of the sun's energy goes straight into heating the air instead. Follow the chain. Dry soil leads to hotter air. Hotter air, as we just covered, has more atmospheric thirst. More thirst pulls even more moisture out of what little the ground has left, which dries the soil further, which makes the air hotter still. It is a loop, and every turn of it makes the next turn worse. Scientists call this a land-atmosphere feedback, and the Intermountain West in early July is a textbook setup for it. Now add fire to that loop. When a fire like the one in Utah strips away vegetation and bears or blackens the ground, it removes one of the last things holding moisture near the surface, and it darkens the land so it absorbs even more heat. The fire is a product of the drought, and then the fire accelerates the drought. That is the machine we are dealing with. Drought drives heat, heat deepens drought, drought drives fire, and fire feeds back into all of it. And the clearest proof that this machine is running at full power right now is a single fire in southern Utah that has outrun every crew sent to stop it. Let me tell you about the Babylon fire, because it is the drought made visible. It was first discovered on June 26th in Utah. As of the latest report, it has burned 96,564 acres, call it nearly 97,000, and it is 0% contained. Sit with that combination for a second. This fire has been burning for about 11 days. It has consumed an area of roughly 151 square miles, larger than many American cities, and in all that time, firefighters have not managed to establish a single line of containment around it. That 0 is the number that should stop you. When a fire reaches this size with no containment at all, it tells you something specific. The fire's behavior is outrunning the ability of crews to fight it. That does not happen because the firefighters are not trying. It happens when the fuels, the grass, the brush, the timber, are dried so far past normal that the standard tactics simply stop working. The fire moves faster than anyone can build a line in front of it. And fuels only get that dry when the drought underneath them has been pulling moisture out of the terrain for weeks. And the conditions on the ground are not helping. As of yesterday, the National Weather Service in Salt Lake City had red flag warnings posted across large portions of Utah. The alert, that means fire weather conditions, are critical. They were citing relative humidity as low as 10%, air that dry with winds gusting up to 30 miles per hour. 10% humidity and 30 mile per hour gusts over ground this parched is the exact hot, dry, windy recipe that lets a fire run. The Babylon fire is not an accident of bad luck. It is what the drought produces when it reaches this stage, and it is not burning alone. The Babylon fire is the headline, but it is one member of a cluster, and the cluster is the real tell. Just north, the Cottonwood Fire in Utah has burned nearly 96,000 acres of its own. In Colorado, the Aspen Acres fire has passed 91,000 acres, and it is only 13% contained. Also in Colorado, the Gold Mountain Fire sits at over 29,000 acres and just 2% contained. The Ferris Fire, more than 51,000 acres. In Arizona, the Pocket Fire, nearly 27,000. These are not scattered, unrelated incidents. They are a line of large fires strung across the same drought-stricken corner of the country at the same time. And when you pull back to the satellite view, the scale gets clearer. NASA's fire detection system logged 935 active fire hotspots across the country in a single 24-hour window. Not all of those are megafires. Many are small or agricultural burns, but the density of them is a texture reading of just how primed the country is to ignite. Where the ground is this dry, almost anything that sparks can catch. Look at the discovery dates on these fires, and you see the pattern even more plainly. The Babylon and Cottonwood fires, the Aspen Acres, the Ferris, the Gold Mountain, nearly all of them ignited within the same 2-week stretch in late June, across 3 different states. When that many large fires start that close together in time, spread across that much geography, it is not a coincidence, and it is not a run of bad luck with careless campers. It is a region-wide condition. The fuels across the entire Intermountain West crossed the same dryness threshold at roughly the same moment, because the same drought had been drying them out for weeks. That is the signature of the disease underneath. Not one fire, but a whole region ready to burn at once. The fire weather is not confined to the usual western map either, and this is one of the more unsettling details in the data. Red flag warnings. Yesterday stretched from Utah into Idaho, where the concern was dry thunderstorms throwing lightning onto tinder-dry ground across Washington state, and, remarkably, all the way up into interior Alaska. The Weather Service in Fairbanks had fire weather alerts posted for the Seward Peninsula and the Yukon valleys, with humidity dropping toward 30% and highs near 80 degrees. Fire weather that far north is a signal that the hot, dry pattern has pushed well beyond the ordinary western fire footprint. Every one of these fires, from Utah to the edge of the Arctic, is the same drought showing its face in a different place. And what is about to make all of it worse is not more fire. It is heat. While the west burns, the southwest is baking, and the two are the same story. Right now, there are extreme heat warnings posted across Arizona and Southern California. In the Phoenix metro, temperatures are running between 111 and 116 degrees. Out in the desert zones, south central Arizona, the San Diego County deserts, the Coachella Valley, the readings climb as high as 117 degrees. Down inside the Grand Canyon at Phantom Ranch, the warning runs all the way through July 11th. Now connect that heat back to the drought, because this is the whole point. Remember evaporative demand, the atmosphere's thirst. Heat like this is that thirst turned up to maximum. Air at 115 and 117 degrees is pulling moisture out of the soil, out of the vegetation, and out of the reservoirs at a punishing rate. So this heat is not a separate hazard sitting beside the drought. It is the mechanism actively deepening it, drawing down soil moisture in the same region where the fires are burning, priming the fuels to burn hotter and faster. And the numbers reflect how stacked the hazards have become. As of yesterday, there were nearly 200 active weather alerts in effect across the country at the same time, including 13 red flag warnings for fire, 8 extreme heat warnings, and 16 heat advisories. Fire and heat posted side by side across the map, because they are being driven by the same dried-out, overheated ground. But here is the part that turns this from a bad week into a dangerous one. The biggest heat is not here yet. It is loading for the weekend. Here is what forecasters are watching move in. According to the Weather Prediction Center's extended outlook, a broad dome of high pressure is expanding over the central United States, and it is set to intensify over the next several days into a major heat event. Across the northern plains this weekend, temperatures are forecast to run 10 to 20 degrees above average. Across the southeast, the outlook calls for major to extreme heat risk, with heat indices, what the temperature actually feels like on your skin, climbing between 105 and 115 degrees. Think about what that does to the machine we have been describing. Every extra degree of heat this weekend raises the atmosphere's thirst by that 7% per degree we talked about, which means more moisture pulled out of ground that is already cracking. Remember that small improvement in the national drought number, the one that came from eastern rainfall? A heat event of this size is exactly the kind of thing that erases marginal gains like that, because it evaporates away moisture faster than a stray rainstorm could put it back. Now, the weekend heat is not going to relieve the drought. It is going to feed it, and it lands on ground that is already at its breaking point. Fuels are already dried past the point where firefighters can hold a line. The Babylon Fire's 0% containment is the proof of that. Now you're about to pour the hottest air of the summer onto that same parched ground. That is why this weekend matters, and why the story is not the fire you can see today, but the conditions loading in behind it. Because behind the heat, there's a bigger force still on its way, one that operates on a timescale of months rather than days. To understand where this drought goes from here, you have to look at the ocean. Thousands of miles away in the tropical Pacific, a climate pattern called El Niño has taken hold, and it is strengthening. The way scientists measure it is the Oceanic Niño Index, and it currently sits at positive 0.98, with sea surface temperatures in the key region running at 28.71 degrees Celsius. That reading puts us officially in moderate El Niño territory, and the trend is still warming. What makes this worth your attention is how fast we got here. Over just 6 consecutive seasons, that index has swung from negative 0.54, La Niña conditions, the opposite pattern, all the way up to positive 0.98 today. That is a full reversal of the tropical Pacific in roughly 18 months, and it matters because El Niño reorganizes rainfall patterns across the entire planet. In its developing phase, it can suppress precipitation across parts of the interior West and shift the storm tracks that would normally bring relief, all while nudging the global baseline warmer. Here is why that should concern you in the context of this drought. If this El Niño keeps strengthening toward winter, the drought's trajectory into the back half of 2026 could deepen before it breaks. And underneath the surface drought, you can see on the map, there is an invisible one. Aquifers like the Ogallala across the southern high plains that have been drawn down for decades. When surface water disappears, people pump harder from underground, accelerating a long-term depletion that never shows up on any weekly drought map at all. So the drought you can measure is sitting on top of a water problem you cannot see, and the ocean pattern now building offshore is tilting the odds toward all of it getting worse. So let me bring this back to where we started and tell you what actually matters going forward. The single most important thing to understand about this drought is that its slow pace is disguising its severity. There is no dramatic moment, no landfall, no eruption. Just 2/3 of a country quietly drying out until a fire gets big enough that you finally look up. The Babylon Fire at 0% containment is that fire. It is the drought forcing its way into the headlines. Here is what to watch in the coming days. Watch whether the weekend heat dome delivers as forecast, because if it does, it will pull moisture out of the west faster than anything can replace it, and it will push the fires harder. Watch the containment numbers on the Babylon and Aspen Acres fires. As long as they stay near zero, it tells you the fuels are still winning. And watch that El Niño index through the rest of the summer, because it is the clearest early signal of whether this drought deepens into the fall or finally starts to break. The honest bottom line is this. One national number improved this week, and that is real. But it is a rounding detail against a drought large enough and self-reinforcing enough that a single fire can outrun every crew sent at it, with the hottest stretch of the summer still loading for the weekend. The question that should be on everyone's mind is a simple one. If the country is already this dry and a fire this size cannot be contained, and the real strength of this El Niño has not even arrived yet, what does the American West and the water supply that millions of people depend on look like when it does? We will be tracking every piece of it, and we will tell you the moment the answer starts to come into focus.